Okay, let's take a look at the graph of cotangent, which remember cotangent is equivalent to 1 over tangent. So it's a reciprocal of tangent, or it's tangent is sine over cosine. We could think cosine over sine, right? It's the reciprocal. I kind of like this because both the graphs I think of tangent and cotangent are kind of weird, but let's take a look at it. Cosine over sine. So if I look at each of these values that have 1 divided by 0, I have a problem right here, right? This undefined. 1 divided by 0 undefined. Cosine over sine. Square root of 3 over 2 over 1/2, we get square root of 3. Square root of 2 over 2, square root of 2 over 2, we get 1. And then 1/2 over root 3 over 2. Remember, you cancel the 2's, we get 1 over root 3, which is going to be root 3 over 3. And then 0 over 1 is 0, right? 0 divided by anything is 0. So let's take a look at those couple values really quick. Put them on the unit, or put them on the graph, and then go from there. Undefined at 0. Remember tangent, because it was sine over cosine, we actually had 0 here for tangent. So what happens is some of these are going to be interchanged. For tangent, we had a 0 here and an undefined here. But cotangent, it's backwards. We actually have an undefined at 0. And then at pi over 2, we get 0. All right, now let's picture some of these values. Square root of 3 to 1. So this is like 1 point something. And then down to 1. And then square root of 3 over 3 is less than 1, right? Because we'd have like 1 point something divided by 3. We'll just call it like 1/2. So tangent had this graph where it had these little, they look like cubics, and then they approached asymptotes. Keeping that in mind with cotangent, really this is all the information we need if we follow that pattern. So I know it's going to do that, but cotangent actually is in reverse, and then we're going to have a problem at pi, so I left these 4 angles over here because we could quickly see, right, tangent is y over x, so over here cotangent is x over y. So 1 over 0, right, I'd get undefined. But then at the angle here at pi, I would have negative 1 over 0 is also undefined. And then at 2 pi, right, I'd have 1 over 0 again, undefined. So every single pi over here at 3 pi, I'm going to have a vertical asymptote. And that would hold true in the negative direction as well. Again, maybe I should have switched colors. That's okay. I'll erase that really quick. Okay, this was heading down, and then it's going to continue to head down, and we can look at why is that really quick, because pi over 2 to pi means we're heading over here, right? We're now in this quadrant 2. And in quadrant 2, remember all students take calculus, only sine and its reciprocal, cosecant, are positive. So therefore I know cotangent is negative. Also remember that all these values in this quadrant 1 appear in quadrant 2, it's just that x is negative. So as we move, we'll get these same values as we did here, right? Except for we'd have a negative because it's cotangent is negative in this quadrant, in the quadrant 2, pi over 2 to pi. You could also pull up a table of values in your calculator. So you'd have to do y equals 1 divided by tan, right? That's cotangent. And then open up your table and you'll see these values, and I would set the you could change your delta x to something like, I don't know, make it pi over 6 or something. That way it's counting, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and so forth. But you would start seeing these values tend that way. As you get to pi, right, they're going to be further and further negative here. Another way to illustrate that is, again, look at this unit circle here. I don't know the values, right? But if I'm like almost at -1, 0, like -0.9 and just something barely greater than 0. I'm not claiming this on the unit circle, but just for argument's sake, 0.1. If I'm doing x over y, right, 0.9 over 1, -0.9 over 1, I would get -9. These values are going to approach -infinity until we get to pi, in which we get an undefined point again. And if you repeat this process, you will notice, or use your graphing calculator or GeoGebra and graph these, this is what you'll see. Okay, it's periodic, it repeats. The difference now is our domain and our range. Well, the range is the same, right? The range is easy, -infinity to infinity. But the domain for tangent, we had a problem at every pi over 2, and then we added pi. Like anything that had a half in it, there was a problem. Now our problem areas are every pi, so 0 pi, 1 pi, 2 pi, 3 pi, and so forth. So for domain, x cannot be n pi, where n is an integer. There are other ways to write it as well, as long as you note that, right, any multiple of pi, we have a problem for cotangent. That works for me.